All right, so we have our rules for dealing with a series circuit. So now we want to apply them and see how we can find all of these different things out about this little series circuit we built here. So the first question is, what is the total resistance, or also known as the equivalent resistance of this circuit? Now I'll notice they're in series, and how I know that is that if I take a single path, there's multiple resistors along that same path, and that means they're in series. So I've identified this as a series circuit. To find the total resistance, I need to just add up the individual resistances. So to get the total resistance, I'm going to go 20 plus 16. That will give me a 36 ohm total resistance. So our total here is going to be 16 plus 20, or 36 ohms. Now the second one wants to know, what's the direction of the current? So the direction of the current, conventional current mind you, always flows from the positive side to the negative side. So this is the direction of the current. It is flowing counterclockwise in this circuit. Now to find the individual currents. So we're going to have to go back over to our rules over here in order to find the individual currents. Well, the individual currents are the same as the total current. So whenever I want to find currents, they're all the same, so I really want to find the total current. And how I find the total current is I use Ohm's law with all the totals. So I know the total voltage, I know the total resistance, and so now I can find the total current. So if I set that up, I have V total equals I total times R total. And so I total is going to be my 12 volts divided by my 36 ohms. So that gives me a value of 1/3 of an amp. Okay, so since that is the total current, that is going to be the current in each one of those. So in each one I have 1/3 of an amp. So 3 and 4 kind of go together because they have the same current. Now, if they would have asked us to find the voltages of each, I'm going to actually have to find the currents first. And the reason for that is I can go from the total into the individual currents. Once I know the individual currents and I know the individual resistances, then I can find the individual voltage. So depending on if you have a series or a parallel, you might have to find current first in a series, or as we're going to see in the next parallel example, you're going to have to find voltage first, then find current. All right, so let's go ahead and finish this out. So we're going to find those two voltages. So we're going to find those using Ohm's law. So V1 equals I1 times R1. So the individual voltage for 1, which has 20 ohms, has 1/3 of an amp in 20 ohms. So we get 20/3, so that's 6.67 volts. And for V2, I have I2 R2, and I end up with V2 is equal to 1/3. Now I could have kept it as 0.333, but I just used 1/3 here just because I was plugging it in a calculator. 16, so 16/3 gives me, what, 5 1/3 volts? Okay. So now I have their individual voltages. A nice little check for yourself is take a look at those two voltages. Those two voltages should add up. So if I add up the individual voltages of all of the resistors in series, I should get the total voltage. So here we go. We have 6.67 plus 5.33. That gets me 12 volts total. Little squeak there on the marker. 12 volts total. That's what I had. So it checks out. So there's our series example.